So I'm going to do a full recording to show you the process. Okay, I'm going to start with the VSync D. So this is the Broward County file. Okay, this is the arterial you try to import. Okay, so I'm going to delete this first. So to delete, hold your right mouse, just highlight, drag, and highlight everything, and then click the delete function. So this whole signal are gone. Okay, you still have other signals coded previously. Okay, what I want to show you is that you send me these synchro, the UTDF files. These 1, 2, 3, 4, 5, 6, 6 of them. Okay, when I try to open any one of them, in fact, only this one has the data. That's why we cannot import all of them at the same time. So for example, if I click this one, there's no data. Okay, it's going to give an error message. You're going to see. Okay, so you see there's no data. Okay, the one that has the data is this one, this PM. Okay, so which I have already opened it here. You can see this, the PM file. Okay, so this is in UTDF CSV format. So let me show you how to import this. Okay, so again, come here under agency. Let's double check, make sure every settings is correct. So edit the current agency, which is Broward County. In fact, see here, the sync time is not midnight. I believe it's 5, if I remember it correctly, 5 a.m. And then the other ones remains the same. Okay, change that. Okay, say OK. Okay, now let's do the import. Go to Agency, Import from UTDF. It's asking, do you want to import the link connections? Say yes. Okay, so I'm going to pick this file. This is the file that has the data. Okay, if I say open, okay, asking signal imported file will be merged because you already have other signals. Just say yes. Okay, now it's asking the subsystem name. Okay, here you just say Pine Island Road between Broward Boulevard and here. So you can give some kind of shorter name to make sure it's easier to remember. You don't have to say PM. So PM is defined here, whether it's AM plan or PM plan. You can just say PM plan here, or you can say PM existing. Okay. Later you can add other timing plans. So you just say OK. So now import completed. Okay, so this is this is the one here. See there? That's your subsystem. Okay, and then you got the whole thing. Okay, you put your cursor here. You will see this is a 160-second cycle, 160-second cycle. I think the error when you try to open the time-space diagram here, PM existing, you say OK. Please fix the following. Okay, it says that this intersection northwest 20 unspecified, so there's a barrier crossing violation. Okay, so later I'm going to show you how to fix the street names, but this intersection is really pull out the synchro here, the 20th street. Okay. Let's see where is the 20th Street. I think down here, yeah, this one. This is where that has the issue, the signal. If you look at the signal, okay, see there phase 2, there's a phase 6. Phase 6, somehow you only have a split of 5. Okay, if you had, just fix this, make it equal, that should have worked. Okay, but you can fix it from here as well. So the 20s, okay, I need to find out where is the 20s. That's 25th, 34th. This is 20th, okay, this one. Okay, this is the intersection, exactly the same intersection. Double click, come to this window, then you go to the timing. This is where you see why that violation, crossing violation. See, 2 and 6 are not the same. You could just, move a little bit now and make it the same. Okay. So this is why you call that error. So if I save this, okay. Now go back to display the time space diagram. And now you can see the time space diagram. Okay, there's few things we need to clean this up. You see the street name there. It says unspecified, unspecified. There's some locations is correct. Okay, let me close this map. Okay, don't save now. You first check to see the signals are at the right location. Looks like they are. Okay, and then the street name. So let's go to the first signal on the top. Okay, you see the street name, there's unspecified. Okay, so if you right click edit signal, then this is where you can change the street name. I think north-south is, okay, so I need to know what is north-south street. North-south, Pine Island Road. Pine Island Road. Is it? Yeah, Pine Island Road. Okay. So go back here, right click, edit signal. So if you pull down here, there's no such street name. Okay. What you need to do is you just say North Pine Island Road. Okay. You can north-south, yeah. North Pine Island Road. And east-west is that McNabb, okay? So change to that. So now we fix the name of this one, okay? Go to the second one, okay? Right click, edit the signal, north-south, that should be Pine Island Road. East-west, that should be commercial. Okay, fix that. Okay, and then you can do this for the rest of the signals. So it takes some time. This also may be caused by your UTDF. You didn't specify the correct name of the street. Okay, and always save. Okay, you will clean up all the other ones. All right, and then you see there are some curves. Okay, there's some curves here. Okay, to add a point to create a curve, you turn here, show hide non-signal node. Okay, when you come here, you just see your mouse, you left click, hold your control key and use your mouse to drag it. Okay. Again, put another point, hold your control key to drag it. So you can add as many as you wish to make it look much nicer. Okay. Here you can do the same. Okay. You have to zoom in to a certain level, click, put it there, and then click, put it here. Okay. Now let's say this is good. The curvature, everything looks good. Okay. Let's look at the time-space diagram again. This is PM. You look at the signal. At the bottom, there's one signal that is 52 seconds. So here's 160, 160, 160. This is a cycle. 110. Then you have 80, 117. Okay, 160, 160, 160. So this will not, the optimization will not work if you have this kind of cycle. So I don't know if this is just a case or there's some program errors here. So this one, the fourth one from the bottom. So we need to make the cycle 1, 2, 3, 4. So this one showing 110. Okay, this has to be some cycle either 80 or 160. So make it 160. And then later you can adjust whatever the split you want. Okay, and there's another one which is the 20th Street. Okay, I remembered. Okay, somewhere is showing 52. Yeah, this one. So again, I don't know if it's running free or it's running coordinated. So if it's running free, just make it to 160. Okay, give all the green time on the main street. Okay, there's another one that is showing 80. 80. Oh, there's 117. This one. So this one definitely needs to be changed to the same cycle. Okay, and you can later adjust the split according to what you want or what's in the ATMS. Okay. Okay, let's just look at the time-space diagram again. If I open this, you look at just the top part. Okay, so this is not going to run very well because, see, this is called a virtual trajectory. This is showing the band. Okay, where are you going to stop? So there's no way you can go through without making those stops. Okay, like here. Okay, so I don't know if this is your existing or this is your optimized. What you need to do is you need to go to each intersection, double click it, go to this timing, and then run this real-time display. Check this against your ATMS. That's what we did before, right? Check if you have the right sequence, if you have the right split and offset. So if you have the right one, they should match. All right. So this is how you imported the PM. If you just want to create another timing plan, let's say optimize the PM, what you can do is you can open this existing. Okay, this is existing. You can see the name here. Using save as, you can say optimized, new or optimized. Optimized 1. Okay, you may have you may try several different options. Okay, now this is saved as an optimized timing. Okay, so optimization, you just right click, optimize. Okay, balance north-south, so I always do balanced. I know somewhere there's one cycle is 80, so that could also affect your bandwidth. All right, so you see this is optimized. Okay, of course there's some minor adjustment you might need to make, but this will give you a band in both directions. Okay, so then you have a better chance of going through several signals without stopping. Okay, so the adjustment, for example, here you don't want green starts here, you don't want the vehicle to immediately stop. Okay, so what you can do is you move this offset. See, now you don't stop, and then the other direction you can lead this. So click lead. Now you got a good bandwidth. So these kind of skills you need to develop eventually. Now, yeah, of course, somewhere else you may also want to adjust. Um, yeah, so I think this overall looks pretty good to me. Um, and then you just save it. Okay, change save. Yes to file. Then when you implement it, make sure you implement this everything correctly. Then you do that real time scan as I showed you. Okay. So now you see you have two timing plans. If I open the time space diagram, you see this is your existing. Okay. And then you can open another timing plan which is your optimized. You can have a side by side comparison. This is your before, this is your after. Okay, so you just need to put this onto your iPad, go to the field like we did last time, drive, record the travel runs to see the timing in the field matches. Okay, so if this is you drive on this timing plan, you're going to make several stops, versus this one should give you minimum number of stops. But again, there are other factors. Is it oversaturated? You know, if it's oversaturated, you still need to stop multiple times. Okay, but if it's not oversaturated, so that's why you need to watch your split also, and then definitely this will give a better performance. All right.